Welcome back, students. This is the Q&A session 17 from the playlist of laws of motion. The topic is constraint motion, and this session is in continuation of the session number 16. So in this question, we have to find the acceleration of this 8 kg block and the tension in the string. So here, this figure was given along with this question. Here, these pulleys are frictionless pulleys. The string is inextensible and massless, and all these four pulleys are identical in nature. These are the rigid supports. These two are the fixed pulleys, and these two are the movable pulleys. This one and this one are the movable pulleys, and these two are the fixed pulleys. The string is inextensible and massless. The pulleys are frictionless, and the value of G is equal to 10 meter per second square. So here we have to find the acceleration of the 8 kg block, which I have depicted here as M3, and this block is moving in the downward direction as indicated by this arrow. So we have to find the value of A3, which is the acceleration of this 8 kg block, and we have to find the tension in the string. Now, since this is one string which is connecting all these four pulleys, and therefore the tension in each segment of the string will be the same. So let us solve this question with the help of the two equations, that is now in the case of the constraint motion, the algebraic sum of the product of all the tensions in the string and the acceleration of individual block is equal to 0. And this is what we have studied in the previous session. And the net force acting on each block is equal to m into A, where A is the acceleration of that block and m is the mass of that block. So I will be using these two equations in order to find the tension in the string and the acceleration of the 8 kg block. So these are the two equations which I will be using in order to find the tension in the string and the acceleration of this 8 kg block. So let us use the first equation. So by using this first equation, the equation which I will be getting with respect to this question is minus A2 plus T into A3 is equal to 0. Now, as per this equation, the algebraic sum of the product of all the tension in the string and the acceleration of the individual block is equal to 0. Now, I have just considered this block, that is block M1 of 2 kg. So here the total tension is equal to T plus T. This is the tension which is acting in this direction. This is the tension which is acting in this direction. So T plus T is equal to 2T. And now, if the acceleration of this block is A3, then the acceleration of this block and this block will be taken as negative, because the direction of motion of these two blocks is opposite to the direction of motion of this block M3. So, from this equation, I will be getting this T and this T will get cancelled out. So, A3 minus 2A1 minus 2A2 is equal to 0. So, this is the first equation which I have got, and I will write this equation on one side of this board, that is A3 minus 2A1 minus 2A2 is equal to 0. So this is the first equation which I have got by using this first equation. So I am just marking this equation as 1. Now let us use the equation number 2. That is, the net force acting on the individual block is equal to M into A. So the net force on this block is equal to, see, the tension in the string is equal to the tension which is acting on this block is equal to T plus T, which is equal to 2T, and this is acting in the upward direction, and this block will move in the, see, if this block is moving downward, then this block M1 and this block M2 will move in the upward direction. So the direction of the acceleration of this block will be in the upward direction, and the direction of acceleration of this block M3 will be downward. Now the this block M1 will move in the upward direction only when T is greater than the weight of the block. If the total tension in the string is more than the weight of the block, then this block and this block will move in the upward direction. So the net force acting on this block M1 is equal to 2T minus 2 into G, that is equal to 20. 20 is what? It is the weight. It is the weight of the block M1. This is equal to M into A, 2 into A1. A1 is what? It is the acceleration of this block. Now let us consider this block of 4 kg. So this is equal to the total tension is acting, the total tension in the string in this case is equal to 2T minus the weight is acting downward, and the total weight is equal to 4 into 10, that is equal to 40, and this is equal to 4 into A2. Now consider this block M3. Now this block M3 will move in the downward direction only when the weight is more than the tension. When weight is more than the tension, then this block M3 will be moving in the downward direction. So the net force here will be equal to 80. This is the weight minus tension in the string. This is equal to 8A3. So these are the three equations which I have got here. So I will be writing now. What I will be doing is now, from these two equations, see, 2T is equal to 2A1 plus 20, and 2T from this equation is equal to 4A2 plus 40. So if I divide this equation on both sides by 2, I will be getting A1 plus 10 is equal to 2A2 plus 20. Or we can say that A1 minus 2A2 is equal to 10. A1, I will be taking this 2A2 on the left side. So A1 minus 2A2 is that this is equal to 10 will go on the right side. So 20 minus 10, which is equal to 10. So this is the second equation now. Okay. Now take this equation now. What I will be doing is now here, I will be taking these two equations. So what I am doing is now, I am just multiplying this equation, that is 80 minus T is equal to 8A3 by 2 on both the sides. So this will become equal to 160 minus 2T. This is equal to 16A3. Okay. Now, if I add this equation and this equation, then I will be getting as this 2T and minus 2T will get cancelled, and I will be getting 140 on the left hand side, and this is equal to 2A1 plus 16A3 on the right side. So this is equal to 70 is equal to A1 plus 8A3. So this is the third equation which I have got. So I will be writing it here as A1 plus 8A3 is equal to 70. Okay. Now I have to find the value of A3. So what I can do is, see here the A1 minus 2A2 is equal to 10. So 2a2 from this equation, from equation number 2 here, you are getting this 2a2 is equal to a1 minus 10. So I will be now putting this value in, the equation number 1. So I will be getting a3 minus 2a1 minus 2a2 is equal to a1 minus 10, and this is equal to 0. So a3 minus 2a1 minus a1, this is equal to minus 3a1 plus 10 is equal to 0. Or we can simply say that 3a1 minus a3, 3a1 minus a3 minus 10 is equal to 0, or 3a1 minus a3 is equal to 10. So this is the another equation which I have got, and I will be writing this equation here. That is 3a1 minus a3 is equal to 10. So let us say this is the equation number 4. 3a1 minus a3. Okay. So now from here, what I will be doing is now, I have to find the value of a3. Now here a3 is 8, and here, here a1 is, here this is 3a1 and this is a1. So what I will be doing is, I will multiply this equation 3 by 3. If I multiply this, I will be getting as 3a1 plus 24 a3 is equal to 210. And this is the equation number 4, which is 3a1 minus a3, which is equal to 10. Now if I subtract this equation from this equation, then I will be getting 3a1 plus 24a3 minus 3a1 minus a3. This is equal to 210 minus 10, that is equal to 200. So from here, this 3a1 and 3a1 will get cancelled out, and I will be getting this 24a3 minus, and minus will become plus, that is equal to 25a3, and this is equal to 200. So a3 is equal to 8 meter per second square. That is, the acceleration of this 8 kg block is equal to 8 meter per second square. Now, let us consider this block again. So here, this block is moving downward, and it will move downward only when the weight is more than the tension in the string, or we can say the net force acting on this 8 kg block is equal to 80 minus T, and this is equal to 8 into A3. And this is equal to 8 into 3 is equal to, A3, and this is equal to 8. Now A3 is equal to 8 meter per second square, so 8 into 8 is, this is equal to 64. So minus T is equal to 64 minus 80, or you can say the tension in the string T is equal to 16 newtons. Okay, so we have solved this question. The tension in the string is equal to 16 newtons, and the acceleration of this 8 kg block is equal to 8 meter per second square. So thank you very much for joining in this session. And in the next session, I will be discussing another type of question which will be having a different configuration of these masses and pulleys. So till then, have a nice day. Bye.